Yeah. All right. For people at home, this is a lesson on the scientific method. Real quick, we have to check uh, why do we think what we think? That's why I was so interested. Why take honors physics at all? We're gonna have to examine that carefully. This is learning critical thinking. When we go to approach an honors physics problem, like I said, it's just multiply or divide. You're experts at that, even at the Algebra 2 level. Okay, you can multiply, but when do I multiply the distance times the time, or do I divide them? What's going on here? You really have to think about it. So we're going to examine a case, and people at home can follow along if you listen carefully. We're going to examine a case where I bet a lot of people think they know what's going on, and really they don't. So in science, we have the scientific method. We always want to use, well, scientists always want to use theory, hypothesis, and experiment. Let's see, let's not bother to change colors. Although, let's not start over there. Oh, there it goes. I can do green. My favorite. The most important. Okay, I'm just annotating on the whiteboard. For people at home, I'll send a picture of the finished product. But the theory is just an explanation. Albert Einstein's theory of general relativity is just his explanation of why the universe acts the way it does, why we have the gravity and the time and the things that we have. And it's such a good explanation. We've never been able to test it and prove it wrong. And it's been tested for over 100 years and I don't know, probably thousands of times effectively. Okay, in science, we have to go with whatever the evidence says, at least for now. Okay, we can always redesign our experiment, we can reconsider our thoughts, and we can get more evidence and check it again. Like, this is really a continuous process. Okay, but everyone mistakes repetition for accuracy. If you hear over and over that something is true, lots of people said it's true, and on the internet, everyone psychologically starts to believe that that's true. Okay, and in this class in particular, we have to stop and check. We're just going to do this with physics things. Okay, but it applies to almost everything. We have to think carefully. So really, the critical one is hypothesis. What is really a testable idea? What question could you really answer with some evidence? Okay, I have a 2-year-old and a 5-year-old. My kids love Buddy the dinosaur. Have you ever seen Dinosaur Train? You might be a little old for that, but awesome if you have seen it. Buddy the dinosaur always likes to say, "I have a hypothesis. It's an idea we can test." Okay, they're using these words are hard to learn, so they're using a kids show to already get them used to that. Okay, it's gonna take some work, but so okay, why do we think what we think? Can we really test what we're thinking about? Sometimes we have to re-examine our ideas, and then what does the evidence show us? Okay, that's the scientific method. Whoops. Okay. Oh, let's get you started. So for people at home, I can put that down. Gotta watch my leash here. For people at home, you can do this in your bathroom. I bet you have a large mirror that you can look at yourself. If so, you can listen to this and take a few notes and then get up and try it in the mirror at home. In the classroom, I have an actual very large floor-length mirror that I'm putting up. Whoop. Okay, and so at first you see your beautiful selves looking in the mirror, checking things out, looks great. Okay, but look at this. See, he's got a shirt on with words. If you put words in front of the mirror, something weird happens. Okay, like my beloved Algebra 1. Good, still starts with A, but then backwards R, B, E. What's going on? Okay, so let's be honest scientists. Write down on your paper, what do you think is happening just right now? There's no wrong answer. What do you honestly think is happening to the image in the mirror? How is it different from just picking things up and looking at them? Okay. Take a minute. While they're writing, I can write. While you're writing. Okay. Back to red. Okay. So humor me a little bit. If you already know what is happening and why, give me like 2 minutes to quiz everyone. Okay. But I bet most people, this was certainly true fifth hour, most people didn't understand exactly what was happening because they had the wrong idea of why it's happening. Okay. Would anyone like to volunteer? Oh no. Oh no. All right. They promised me a longer cord. Let's see what they can do. Okay. So, I'm not going to judge. You can just judge yourself. It seems at first, so try this at home with a letter or with a shirt with lettering on it or with a sign. Hold it in front of the mirror, and it looks like things are flipped left to right. The words in the mirror are backwards. Yeah? So if that's true, if the explanation is left and right are backwards in the mirror, then when I move left in the mirror should move right, right? Left and right reversed. Or if I raise my right hand in the mirror's guy's hand on the left side should raise, shouldn't it? Oh, they didn't want to think about that. Okay, be honest with yourself there on your paper. I'm gonna look that you have some work as honestly as homework and stuff, but I don't care if it's right or wrong at first. Everybody's usually wrong at first, and that's good. You need to learn that your basic assumptions about physics, some of them are right, and some of them are wrong, and the mirror is usually wrong. So here that's an idea I can test. If I put my right side up in the mirror, is his left side going to go up? If I move right, does he go left? No, I don't think so. You can try it yourself. If I move my right hand, the right side, like pick a side of the room, the right side goes up and the left side. It kind of looks like a left hand, but it's not my left hand with a ring on it. So it's not flipped left to right. And if I move right, watching my cord, then the mirror moves right. And same with left. Oh no. Now you get a chance to be a real good scientist. What didn't I try? And what could be going on here? Up and down, that's a great thing to try. Okay, we're getting warmer, but up is up, and down is still down in the mirror. You're almost there. I'm excited. I wish I remembered your name. I'll do better. That's oh, is near and far the same in the mirror? Let's try. This is science, so we really should give them names, right? In math class, they weren't just wasting your time with x's to the right, maybe minus x's to the left, y-axis is up, and minus y-axis is down. We need a third axis for this problem. And it doesn't matter which way we flip it. It will later in about 9 or 10 weeks. We'll get back to this for something serious, and it will matter. But let's call that the z-axis because we just had x, y, z. Let's say the positive z direction is away from me into the mirror. If I move myself, you can see it happening already. If I move in the positive z, the reflection comes negative. It comes back at me. Okay, and if I move farther away in the mirror, the reflection moves farther from the mirror, but that's the other way. Like if I move back towards you, are observers, my reflection moves away from you, not towards. It's that direction. Something is flipped, but it's not left, right. It's not up or down. Great idea to test it, though. We had to make sure. People just sit there the same distance from the mirror and they don't try forwards and back. It's forwards and back, towards in a way that's flipped. So the letters look backwards. I wish I don't, no way to force you to be honest here. I wish I knew who actually knew that before today. Some years people are really honest. Some years people actually know, which is why I stopped doing this example for a while. But in some years, I think people fool me. Oh yeah, I knew about mirrors. I knew that. We'll see. So actually, the image in the mirror is as if the book or the words were transparent and you're seeing them from the back, right? It reads Algebra 1, okay? And over here is starting with the 1. If you could see through the book, you have to imagine. Maybe I'll get a transparency. So many things to do. If you could see through the book and read it that way, that's what you're seeing. You're seeing the mirror image as if you were clear and you could somehow see yourself from the back. Right? The mirror has flipped everything through itself. Okay? We will next semester, one way or another, we'll do an optics unit where we actually examine geometrically why that flip happens. Okay, but that's going to take more than even 18 weeks to get there. That's got to be third quarter, maybe fourth. Okay. Any questions, comments? Okay, I'll leave the mirror up there for just a minute. We will then talk about course expectations. It's 2:10, so we have 15 minutes. Perfect. Okay. We'll ramble about courses for 15 minutes, and then you can be done. I did push record, and we got 12 minutes. Okay.